The other aspect is this. Actuators and technology has gotten to a level, okay, in which what we teach them from the theory point of view for a mechanical system is essentially the computer is a software version of a spring and a damper. So I always have to talk in these terms to mechanical engineers. They understand a spring, they understand a damper. That's the shock absorber on your car, okay, right? Yes. So technology on the computers now are fast enough, and actuations are fast enough that you can do it all in software. So imagine if you're in a car, okay, and you have a certain suspension that comes in. You're not comfortable in the ride, and you decided, oh man, I want a stiffer car, or I want a car that's more relaxed. Well, what do? You have to go to the auto shop, right? They have to take apart the wheel, they have to take the whole suspension out, they have to take and replace the spring. Imagine if that was all in software, and you had a keyboard in your car, right? Then all you do is punch the keyboard. Yes. And then it'll change, and that's where the technology is going. That's why software is very important to a mechanical engineer. Right? There's still a limit, right? I mean, obviously.
But you keep on.
But it's clearly there. So all the stuff of, then there's a lot of things that, now there are aircrafts, military aircrafts that are flown where, the best trained pilot can't fly it if there isn't a computer there.
Do you find any one or two of your students got it and find something?
Oh, I find a lot of them.
Something new and surprise them as well?
What?
Surprise the students as well, but because they can find something that they never thought.
Oh, absolutely. Well, of course. Because most students that come in here didn't have any idea of the programming. Okay? I mean, programming in this sort of type of fashion.
Yes.
Oh, yeah. I mean, that's part of the enjoyment of teaching. Part of the enjoyment of teaching is you always get a handful of students that all of a sudden you see them. You literally see the light bulb pop in their head.
So it's excite the students, I believe.
Yeah, all the hands-on
more and more.
The season. Yeah, there's we more and more. I mean, so what happens is this: the way that the way that the university is structured and what the main, especially here on this campus, is the university is a research engine. That's really what its main course is. Okay, is to do research here, fundamental research, not like product research or product development.
Not like these manufacturers.
I mean, these are literally fundamental research. I mean, there are research that are going on here that probably in my lifetime I won't see it applied. Okay, it's just
different kind of research.
but this is not. I mean, and physics. Physics even way beyond that.
That's right.
Okay, which is also here. And this is sort of where the campus was famous for, was really from the physics department and all this stuff. But this is, in engineering is sort of really applied physics, okay?
That's correct.
But yeah, definitely a lot of the research, in my lifetime we'll probably not see the commercialization of it. Okay, that's because it's just very, very early stage science, and it takes a lot of years to develop it so that it is commercializable. Okay? So, so what happens is, in order for that engine to run, the university has to pick sort of the cream of the crop, okay? So really, so what happens, okay? If you are in the cutting edge of technology or research, if you're in that cutting edge, what's going to happen? Okay, most students that come along from anywhere, if you're not training them, okay, most of these students that come from anywhere, they're going to be lost when they come in here. Okay, because the research is at some point really leaps and bounds ahead of anybody else that have seen it. Okay, so what happens is the training program or the instructional program and the need for having the best of the best as a pool is really to train them so that we don't ever have a lag. And that's what the student pool really is for, is to feed the research engine. Now, as a side effect, the ones that don't quite make it, at least hopefully gets out of here with a degree.
Oh, I see.
Right? Well, you might not. I mean, then the whole thing becomes a philosophy. But really, the inner operation, right? The inner operation of the system is, of course, we want to pick out the cream of the crop. We want to be able to, and that's how you get the competitive edge. And that's why the curriculum is very challenging. Is in a sense to weed out the best. Okay, but then of course, as a side, you want to also give the students, right, a good training. They'll come out, and because they go through this sort of tough program, they've sort of faced it all, and because we are here as a research institution and try to train them for research, right? Essentially, these students aren't really, how do you say, the ones that excel, right, are the ones that sort of get it, and they're the ones, I mean, we look for the ones that can think outside of the box. We want the students to push the bounds. So we don't just teach them, you know, books, right? Anybody can solve problems in a book, given time. But you can't teach creativity. That has to sort of be discovered. You can't. You're missing. And there's always, and believe it or not, right? Even in the 4 years, you often can see it. You can see some of these students. They're just very, very different. One, they won't follow by the rules. They're also the ones that are tough to deal with. Okay, but they push you.
Okay.
Those are the ones that you want. Those are the ones that I actually end up developing friends with. I treat them as colleagues here.
Oh, that's...
Oh, absolutely.
Oh,
absolutely.
That's something different, yeah.
They are a step away from being... So yeah, I teach my class a little bit different. The department hasn't kicked me out or hasn't called me in and said there's in trouble. But it's very different. And some students can't take it. Some students need to be spoon-fed. They're totally at a loss. Okay? So, but I tell them early on, first day of the lecture, I'll sit there and go, hey, look, you guys are a step away from being a real engineer. What I'm here for is mainly to the benefit to the ones that are not going to the research path. Okay, so I'll get a percentage of students that are in my class, and usually they leave, they'll drop out.
Oh.
Okay,
So
not drop out of the class, but they elect not
yeah.
to take the class, mainly because it's not theoretical enough for them. And there are. The majority of the students that come to this school actually are of that caliber. The ones that really want to just stick on the theory, they're brilliant mathematicians. And those I actually don't even want in my class. Because at this stage, right, they are way beyond in terms of theory that even than I am. They will pose questions that I can't even answer. Okay, that's the caliber of the students that I get here. But on the practical hand, it's very different because all the trainings in the previous years, none of the other professors train them in the practicality. That's my job here. My job is to have them be able to hold a screwdriver. My job is for them to know. Yeah. My role is totally different. My role is so that they know how to have the scope. My role is that if their theory does not work, they need to know why.
Yeah.
Okay? And they need to know why by measurement and not by just math. Because for math, they'll actually solve it. But somehow the physical system will bring about where, okay, there's a little tweak in the theory that's, yeah, it's great in pure math, but it's not great in here. Something is wrong. And that's sort of my job. My job essentially is to sort of hopefully bring that gap a little bit closer. Because they need to be, you know, some percentage of it needs to be commercialized. Right? So there's going to be room where there are some people that won't even see daylight, they'll never even see any of these things, they're just in front of the computer and they come up with brilliant, brilliant mathematical solutions. It is no doubt. Okay? It's almost equivalent to, you know, Shakespeare and poetry, but in math. And that's what happens, that's all here.
Applicability is something
else. That's
a
different story. Right? And then that's sort of my job that's here. So I get a chunk of the students, and most of my students will end up graduating and will end up working. I mean, working in the industrial side rather than following the path of academia.
Oh, okay.
So that's sort of the difference.
But for you, as a lecturer, what type of students would you like to be in your class? Yeah.
The ones that don't need to sleep. The ones that are hard workers, the ones that don't give up.
Okay.
Well, I mean, obviously, but they by the time they make it to my class, I have no problems with that. Okay, literally, they're hard workers.
Oh.
The only thing that I wish that they would do is, of course, allocate their time a little bit better. Okay.
Oh, okay.
Because very often about this time, and I stress that, and there are some. There's usually one group out of, like, for instance, this semester, I have 60 students, I have 16 groups. Okay, they all work in groups because, believe me, as an engineer nowadays out in the real world, you're not a single sole person. You're always working in a team, so you might as well get used to that.